Greeting guys. Today we are going to solve physical chemistry problem. By the way, welcome to my channel. So the problem that we are given today, it says the data in the table were collected for the following reaction. So A, B and C was reacting to give us a certain product. So in the table, if you check, we are given A, B and C and their concentrations. So in other words, this is a list of the concentrations of A. This one here is the list of concentrations of B, and this one here is the list of concentration of C. And then here, this one is the rates or the initial rates. So the question requires us to determine the order of the reaction for each reactant. Which reactant are they talking about? We have three reactants, so in other words, we need the order of A, B and C. And of course, after finding the order of each and every one of these, we are required to write the rate law expressions. So without any waste of time, I want us to have a look at this table before we start answering the question. Let's assume now that the first part, this line here, let's say it's experiment 1. So actually let me write it for you. Let's say this is experiment 1. So in other words, experiment 1, I'm referring to these values here, this line here. So let's assume this is the experiment 1, right? And then this one here, let's say it's experiment 2, 0.819, 0.763, 0.400 and 9.0. Let's say it's experiment 2. And then let's say this one is experiment 3. You don't necessarily have to write this experiment part, just writing it for purpose of teaching so that you can understand what I'm talking about as we proceed. So let's say this one now is experiment 4, right? This values here. So I want us to analyze this table in general. If you check concentration of A for experiment 1 and experiment 3 and experiment 4, it's constant. I'm saying it's constant because for experiment 1, 3 and 4, the concentration of A does not change. That's why I'm saying it is constant. You can see it's 0.273, 0.273, 0.273, except only on experiment 2 whereby it was 0.819. So I also want us to check B. If you check B, you will realize that for experiment 1, experiment 3 and experiment 4, actually not experiment 3, experiment 1, 2 and 4, you will realize that B is constant. I am saying it is constant on experiment 1, 2 and 4 because on experiment 1 is 0.763 the concentration, and on experiment 2 is 0.763, 0.763, even on experiment 4. So in other words, it is constant, except on experiment 3. Let's check C. So this is the list of concentration of C. You will realize that C was constant on experiment 1, 2 and 3. It was constant. I'm saying it was constant because you can see that it was 0.4, 0.4, 0.4, right? So if now we check the relationship between A, B, and C for experiment 1 and 2, let's take experiment 1 and 2. You will realize that for experiment 1 and 2, both B and C was constant except A for only experiment 1 and 2. In other words, forget about 3 and 4, forget about experiment 3 and 4, forget about this part for now, and only focus on experiment 1 and 2 only. If you check experiment 1 and 2, you will realize that B and C are constant. Their value does not change, as you can see, right? But A is the one that is changing. So this simply means that the change in the rate was due to the change on the concentration of A. So in other words, the change in the rate was due to the change in A, or the changes made on A. So now this now give us a go ahead to say, if now we are only focusing on experiment 1 and 2, let's write the rate. How was it going to look like? So in other words, let's start with the rate for experiment 1 and see something. The rate for experiment 1, just because B and C does not change like that, they are constant, but this one, A, is the one that is changing. For experiment 1 and 2, we can come and say rate. Let's write rate. Let's say rate 1, meaning that we are talking about experiment 1, right? So in other words, this one here is just necessary mean that we are talking about experiment 1. So in other words, we are talking about this line only. That's what this one mean. That's what this one here mean. It simply means I'm referring to only this line, right? So it's going to be equals to K, obviously, and then we have the square brackets, the concentration of A, the one that was not constant, right? Close brackets. And then this one, we don't write them, right? Why? Because they are constant. Are we together? So in other words, we are going to focus now on this one that is changing, right? Which is A, right? And then from there, we will say to the power, let's say a letter P, whereby P is the order and then of the reaction. And then let's write even one here to indicate that this concentration that we are talking about is not any other concentration, but it's concentration on experiment 1, meaning that this one here simply means that we are referring to experiment 1, and you will see that we have only one value of concentration of A for experiment 1. It's only this one, right? Because this one is for experiment 2, this one is for experiment 3, this one is for experiment 4. But in this case, we are referring to only this value, whereby it's what is for experiment 1. And then let's now say this is equation 1. Let's make it equation 1, right? From there, let's now write the rate for experiment 2. The rate for experiment 2 will be referring to only this line now, the second line, right? So this is for experiment 2. I will write the rate. I will write even 2 here. These 2 only indicate that I'm referring to experiment 2 this time around. I'm referring to these values. But again, just because in these two experiment 1 and 2, B and C are constant, I'm omitting B and C when I write this rate. You can see that B and C are not part of this equation. Why? Because even if we write them anyway, they will cancel out anyway. It's the same. They will cancel out. So I didn't write them because anyway, even if we write them, they are going to cancel out. Isn't that if you are going to divide this by this, they are going to cancel out at some point? So that's why we didn't write them. We focus on this one that is changing, which is A. So we are going to have again K square brackets A, close brackets, to the power P, whereby P is the order of the reaction. And then this 2 here is the experiment 2. It's for experiment 2. So whereby experiment 2 is this part. So we are going to say this is what? Equation 2. And then if now we come and say equation 2 divided by equation 1, so it simply means that we are going to write this rate 2, we divide it with what? With rate 1, and then we'll say equals to this one divided by this part here. And by the way, the rate, or this rate 1, is the rate on experiment 1, which is what? Which is this value here. The rate 2 is the rate for experiment 2. Experiment 2 is this one. These are concentration, concentration, concentration. This is the rate that I'm talking about. So which is going to be rate 2. So let's divide and find out what we are going to find. So we are going to have what? Let's say rate 2 divided by rate 1. So rate 2 divided by rate 1 is going to give us what? It's going to give us this part, Ka square brackets A 2 to the power P, right? Ka 2 to the power P divided by Ka 1, this one here, to the power P, right? So from there, we can substitute the value. If you check clearly, this A1 is the concentration for A for reaction 1, which is this one here. And it's only this one because for experiment 1, we are referring to this line. And on this line, the concentration of A, it's only this one because this one is concentration of B, this one is for C, this one is not a concentration, it's a what? It's the initial rate. So in other words, the only concentration of A for experiment 1, it's only this one, which is 0.273. So what about rate? Rate 2 over rate 1. Rate 2 is this rate that is here for experiment 2, right? For experiment 1, this is the rate here that is here. So we are going to substitute for rate 2. We are going to write what? This one here, 9,0 mole per liter per hour divided by the rate 1 is going to be this one, 3.0 mole, like that, right? Per liter per hour, right? So from there we're going to say equals to K, and K, it's rate constant actually. It's going to cancel out eventually. So this K and K, they're going to cancel out actually. I was not even supposed to write them here because they will cancel out eventually because it's the rate constant, right? It's the same for this reaction A and B. So now from there we are going to insert concentration for experiment 2 of A. Experiment 2 is this one, concentration is this one, right? It's not this one. This one is for experiment 1. It should be underneath, right? On top is for experiment 2, which is experiment 2 is this one. So the only concentration on experiment 2 of A, it's only this value, which is what? 0. Let's copy it, 0.819, and then what was the units? Mole per liter, close brackets, right? To the power P. From there, divide by K. What about the initial concentration now for experiment 1 is 0.273. So we are going to write 0.273 mole per liter to the power P, like that. So from there, this K is going to cancel out with that K, right? And then after that one, 9 divided by 3 is going to give us 3, right? And then it's equal to this one. If you press a calculator, 0.819 divided by 0.273 is going to be 3. And then this P now will come and be like this. So in other words, we are going to have 3 to the power P. 3 is equal to 3 to the power P. And then from there, if you check, this 3 is more like 3 to the power 1, right? And then if now the base are the same, when you see we have 3, we have 3, it simply means that even P is going to be equals to 1. So in other words, the value of P is going to be equals to 1. What does this 1 mean? This simply means that the order with respect to reactant A is the first order. So in other words, we have started now determining the order of the reactant, of each reactant. So in other words, we determine the order already for what? For reactant A. We are going to find out the order for reactant B. We are still going to find out the order of reactant C. So how do we continue and go about finding the order of this one? So we just go and check whereby this B, if we want to find the order for B this time around, we check a point or the experiment whereby B is not constant, but the rest, A and C, are constant. So for example, we can check on experiment 1 and 3. If we check on experiment 1 and experiment 3, you will realize that on experiment 1, A is constant because it's 0.273, even here on experiment 3 is 0.273, right? Same applies to C on experiment 1 and 3. You will realize that is 0.4 and 0.4. So in other words, for experiment 1 and 3 only, A and C are constant. B is not what? Is not constant. So this simply means that for experiment 1 and 3, the change in the rate must be due to the change made on what? On B. So in other words, to find the order of B, we are going now to consider the experiment 1 and experiment 3, because we know that for experiment 1 and experiment 3, B is the only one that was changing. Can you see experiment 3? We have 1.526 and 0.763. But for A and C, for experiment 1 and 3, is constant. It doesn't change. It's 0.273, 0.273 for A. Is 0.4, 0.4 for what? For C. So let's work it out and find the answer. So in other words, it's experiment 1 and 3. We are for rate, we are going to have rate 1. This is the rate 1. And then I wrote B here. B here because B is the only one that was not constant, right? On experiment 1 and 3. So this one is the same one here for experiment 1. This 3 here is the same 3, or it represents this experiment 3 here. This 3 also is represent the concentration of B for experiment 3, which is this one. This one here for B, it represents the concentration of B on experiment 1, which is this one here. So from there, let's work it out and find the answer. So in other words, we are still going to do the same procedure whereby we are going to divide equation 2 by equation 1. So when we divide equation 2 by equation 1, we are going to have rate 3. Rate 3 is this one, right? Divided by rate 1 is going to be equals to K square brackets B to this order Q. This time around, order is Q. Can you see the order is Q? The previous one, order, we said is letter P. But this time around, we assume that is letter Q. And actually, it does not necessarily mean you can use PQ. You can use any letter of your choice. So now, from there, we write 3 here to indicate that we are referring to experiment 3, which is only this line, right? From there, we divide by K, square brackets B, close brackets Q, and then we indicate that we are referring to what? To experiment 1. From there, let's now talk about rate 3. Rate, I mentioned to say this 3, it simply means that we are talking about experiment 3, right? And then in terms of rate, this is the concentration, this is the concentration, this is the concentration. For experiment 3, we have only this value as our rate. So in other words, for rate 3, we are going to write what? 12.0 mole like this, right? Per liter per hour, right? And then what about rate 1? Rate 1, this one simply means that we are talking about experiment 1, which is this one, and we are talking about rate. This one is not a rate, this one is not a rate, this one is not a rate. All of these three are what? Are the concentration. The only rate for experiment 1 is this one, which is what? Which is 3. So in other words, we are going to divide by what? By 3.0 mole per liter per hour, like that. And we are going to say this is going to be equals to K again, square brackets. What about now the concentration for 3, or the concentration for experiment 3 for B? Experiment 3 is this one. This is the concentration of A, we are not talking about it. This is the concentration of B, we are talking about this one. So it's going to be what? 1,526, right? Mole per liter. We close brackets, we say to the power what? Q. We divide by K, square brackets. Let's now talk about the concentration of B for experiment 1. Experiment 1 is this one. Concentration of B is this one, is 0.763. So we write 0.763 here, mole per liter. We close brackets to the power Q. So from there, 12 divided by 3 is going to give us what? By the way, this will cancel each other, isn't it? K and K. Right from there, 12 divided by 3 is going to give us 4. And we are going to write this equal sign. We divide this by this. We got what? We got 2. We don't forget to put what? To the power Q like this. But then, if you recall, mathematics do allow us to say what? To say this 4 is more like 2 to the power 2, isn't it? So I will write 2 to the power 2 instead of writing this 4 here. And I will say the same 2 to the power 2, which is the same as this 4, it's equals to 2 to the power Q here. And now we can say now Q, it's obvious that our Q should be equals to 2. So this simply means that this Q, can you see that it was to the power Q, to the power Q? It stands for order of the reaction. So in other words, now we just found that the order with respect to B is 2. So in other words, is the second order with respect to B. So we are gradually getting there. We have already found the order of each reactant not for each reactant, but we have already found the order for A and B. We are left with finding the order with respect to C. So how do we go about this one? We come again and check. Which experiment do we have A and B constant and the C is the only one that is changing? If you check 1 and 4, you will realize that for experiment 1 and 4, A is constant, right? 0.273, 0.273. For experiment B, for B in experiment 1 and 4, we have 0.763, 0.763. So obviously A and B for experiment 1 and 4, they are constant. What about C? For experiment 1 and 4, C is not constant. So this simply means that for experiment 1 and 4, the change in the rate must be due to the change in what? In C, or the concentration of C. So without any waste of time, let's quickly go and work this one out. We are going to start with the same procedure that we just applied here, whereby we are going now to focus on experiment 1 and experiment 4 in terms of C, obviously. So this is what we are going to have. We are going to have rate 1 and rate 4, right? Because we are talking about experiment 1 and experiment 4, knowing that A and B for experiment 1 and 4, they are constant. So we have 1 and 4. Again, we are going to divide equation 2 by equation 1, whereby we are going to have what? Rate 4 over rate 1, or divide is equal rate 4 over rate 1 is equal to this one. But this time around, if you check the order of this reactant, I just put letter Z or Z. So this is letter Z for the rate, for the order of the reaction. So now let's substitute. Rate 4 is only going to be this one, which is 6 here, right? So divided by rate 1, which is 3. So in other words, we're going to have 6 over 3, and then K will cancel each other. What about the concentration? We are only focusing on concentration of C because we are talking about C here. So the concentration is 0.8 divided by 0.4, like what I did here. And then from there, we are going to do what? We are going to say 6 divided by 3 is going to give us 2. And then this 0.8 divided by 0.4 is going to give us 2 again to the power Z, or letter Z. From there, we know that any number is like this 2, when it's 2 like this, it has 1 on top, right? So in other words, this simply means that we have 2 to the power 1, which is going to be 2 to the power, let's say, letter Z, whereby this now will simply means that the letter Z, or the order for this reactant, is going to be equals to 1. And what does this simply means? This simply means that we work and find out that the order with respect to A is 1, the order with respect to B is 2, the order with respect to C is 1 again. So what does that mean? This simply means that our rate law expression is going to be like this. We are going to have rate is equal to K, obviously, square brackets a to the power 1, right? Because it's the first order with respect to a, right? And then from there, square brackets again, we have b, right? Square brackets to the power 2, isn't it? Because it's the second order with respect to b. From there, we are going to have what? C to the power 1, like that. So this is going to be our rate law expression. And we can tell which order is this one, or the overall order of this reaction. So after this one, there are some of the questions that we can be asked to find, like, you know, finding this value of k, which is obviously going to be simple because already we know the order of this reactant, like that. So thank you so much. Keep watching these videos. Hopefully I will send more video in due time. If you have some questions, kindly comment on the comment box, and then I will look at your question, and try by all means to get back to you in a form of a video and answering all those kind of questions. I thank you.